We'll practice using conservation of energy and work energy theorem to analyze motion. Here's the problem. A 2.0 kilogram cart starts from rest at the top of a frictionless ramp 5.0 meters high. At the bottom, it slides onto a rough horizontal surface with coefficient of kinetic friction 0.30 and eventually stops. Part A. Find the cart's speed at the bottom of the ramp. Part B. Find the distance it travels on the rough surface before stopping. First, find the speed at the bottom using conservation of energy. The potential energy at the top converts entirely to kinetic energy at the bottom. You set gravitational potential energy equal to kinetic energy, mgh equals 1/2 mv squared. Cancel mass and solve for v. V equals the square root of 2gh, which is the square root of 2 times 9.8 times 5.0, equals the square root of 98, which is 9.9 meters per second. Now for part B. On the rough surface, the kinetic energy is removed by friction work. Set kinetic energy equal to work done by friction. 1/2 mv squared equals mu underscore kmgd. Cancel mass and solve for d. D equals v squared over 2 mu underscore kg. Substitute the values. D equals 98 over 2 times 0.30 times 9.8, which is 98 over 5.88, equals 16.7 meters. Rounding to two significant figures, the stopping distance is 17 meters. Remember, in the absence of non-conservative forces, mechanical energy is conserved. When friction is present, the work done by friction equals the change in mechanical energy.